I'm Colin Smith from the Research Communications Group at Imperial College London, and I'm talking to Dr. Gareth Collins from the Department of Earth Science and Engineering. Dr. Collins took part in a study to determine what caused one of the largest extinctions on Earth 65 million years ago, which devastated the planet on a global scale. Gareth, what caused the extinction?
Our work suggests that the extinction was caused by a large asteroid impact. The asteroid was probably more than 10 kilometres across, so about the size of the Isle of Wight, and struck the Earth at a speed of 20 kilometres per second. That's about 20 times faster than a rifle bullet.
What does this animation show us?
The animation is a numerical model of the crater formed by the asteroid impact. It shows the asteroid blasting a 100 kilometre wide, 30 kilometre deep hole in the Earth's surface, and the subsequent gravitational collapse to form the broad 180 kilometre diameter crater that is now buried under the Gulf of Mexico.
Can you explain what the right side of the animation shows us, and can you also tell us what the left side shows?
The right side shows the decimation of different layers of the Earth's surface. The soft sedimentary rock sitting on top of Earth's hard crust, the grey, and with the mantle beneath. That side shows how the whole of the Earth's crust was deformed by the force of the impact. The left side shows contours of temperature, with temperature increasing from blue, cold, to red, hot. The brightest red represents rock melted by the impact. So you can see that a thick sheet of melt, a few kilometres deep and about 80 kilometres wide, forms in the centre of the crater.
How does this graph relate to your research?
We have compared this model and others like it with observational data from the Chicxulub crater to understand just exactly how big the asteroid was that struck 65 million years ago, and hence what the environmental consequences of the impact were likely to have been.
If we could take a time machine and travel back to the moment of the Chicxulub impact, what would we see?
Well, if we were fortunate enough to view the impact from a safe distance, the first thing we would see would be an enormous ball of hot rock and vapour, which rapidly expands from the impact site. For about tens of minutes, this would have been very bright, almost like a second sun on the horizon, which is why it's often referred to as a fireball. Beneath this, a large crater would have opened up, very much like that shown in the animation, throwing large amounts of rock into space, which then rained down back all over the Earth.
Can you explain the environmental devastation that the impact would have caused around the world?
Well, that's hard to know precisely, but probably in the vicinity of the impact, heat from the fireball and rock re-entering back into the atmosphere would have grilled the biomass, causing fires and burning anything too large to find shelter. The impact probably also caused an earthquake of a magnitude greater than any that we know of in recorded history, and the ground shaking from this would have been felt thousands of kilometres from the impact and caused landslides, most likely all around the continental shelf at that time. The impact was also into a shallow sea, so inevitably a large tsunami wave would have been formed and travelled across the Gulf and swept along the coastline. But on a global scale, it's the dust and aerosols that thrown up by the impact into the atmosphere that would have had the most devastating consequence for life by blocking out sunlight and cooling the global climate for years after the impact.
Could this type of asteroid impact happen on Earth again?
Absolutely it could. The question is really when, not if, another impact of this size will occur. Fortunately, though, we know that these impacts on this scale are very, very rare, occurring about, once every 100 million years or so on average.